English?
Because they're already dead. Well, trees grow back. It's okay.
Trees grow back?
Trees grow back. Trees don't grow back. They don't? No. Again, I'm not going to shout. I'm going to speak at this voice level, and if you can't hear me, then shush the people around you so you can. So, for today, for proofs, I want to make sure you guys remember that within a proof, if you notice that the proof statement, like what they want you to prove, is a theorem or a converse of a theorem, you cannot use that theorem within that proof. So make sure you guys are really careful looking at the directions. This one says that given A and B are parallel and that angle 1 is congruent to angle 3, I'm trying to prove that the other set of lines are parallel. Alright, so this is not one of those weird situations where you have to avoid circular reasoning. So how would I start this one? Yes, Brody. Okay, put down the given. So, well, we're going to start with the first given. Right, and I know that because it was given. Okay. Remember, the way that you work through a proof is you're going to write down the given, and then you're going to tell me what you can conclude immediately after that. So if I know that A and B are parallel, so that's these two lines are parallel, what can I conclude based on that? 1 and 2 are 4. What can I conclude about them? That they're equal. Yeah. Right, what? Yes. Oh, I mean, angle 1 is equal to angle 2? Yes, you could write that. Yes.
Like I mean after another step.
Okay.
Why did you do it like you try it after that step?
Right, 2 is equal to 1?
Yeah.
And the other order? No, you pick the order that you want. Doesn't matter what order.
Don't worry about it, just hate it.
What reason would I give for angle 1 being congruent to angle 2?
Alternate interior angles.
Oops, that's side. Alternate interior angles. Now, quick question. Brody, if you have paper, maybe write it by hand. What we're doing. Do you have paper? Do you have paper? Okay, well, I have paper you can borrow. I have my phone. Well, then don't distract us. Alright. Is this the theorem or the converse of the theorem that I'm using right here? Yeah, it's the theorem. You have to remember, if you're going from parallel lines to the angles, that's just a regular theorem of postulate. If you're going from angles to the lines being parallel, the reverse of that, that's when you use the converse. So make sure you're really careful. Alright. I can't really get anything else from the fact that the two lines are parallel. I don't have any other relationships that I can use. So what would I bring in now? The other given.
Other given.
No.
You should just draw in cursive.
I tried doing that. Alright. What can I conclude now? I'm bringing in new information, so what can I say now? Yes. Angle 2 equals angle 3. Now, I had a lot of people in my third period that were like fussing when I said this, but remember, you guys can use substitution and transitivity interchangeably when you're talking about equal. When you're talking about equal, you can use transitive and substitution interchangeably, right? So here you guys can pick whether you want to write substitution, because I substitute this 2 for that 1, or you can use the transitive property, which says that if A is equal to B, if A is equal to B and B is equal to C, then you can see those two are equal to each other. It doesn't matter. It is up to you. Which one would you like me to write on the board?
Substitution. Because that's not A.
It is still the transitive property. They just wrote the first line in the wrong order. So if you had written it as 2 to 1 and then 1 to 3, it's still transitive. Yes.
What is the way the third line? What if you put both the givens and then we put the 1 equals 2?
That's not good. Okay.
That's good.
That's great. That's awesome. Fantastic. All right.
Can you put them in the C?
Now what? You can, but it makes it a little more confusing. Now what can I do? Do I have enough information or do I need more? I have enough. Do you guys see? I now have that 2 and 3 are congruent. Why would that be enough to prove that those other two lines, K and M, are parallel? They're corresponding angles, right? Yeah. Well, that's not what you would say is the reason. The corresponding angles postulate of the converse.
Yep.
Hold on. Okay, I'm about to explain. So remember, corresponding angles is postulate instead of theorem. I'm not going to be too picky about that. Just try to remember. Now, the reason why this is the converse instead of just the postulate is because we're starting with the angles being congruent and then concluding that the lines are parallel. If you start with the angles and conclude that the lines are parallel, that's when you have the converse as opposed to just the normal postulate. Okay? Proof done. Everybody okay with that? Yes, Keely.
I just still have a question about postulate or a postulate. Is it from lines to angles or angles to lines?
The postulate is just a specific word for the corresponding ones. So it could have been the alternate interior angle theorem converse as well if we were using different angles. It's only the postulate because of the corresponding angles. All right. What about this one?
Jake?
This is a fill in the blank, so I have it kind of set up the structure here. So I have two givens that I'm going to give it first. So I'm going to say that J is parallel to L and L is parallel to K. Those are two givens. Now, I'm not trying to prove the transitivity property in the proof. Like, I'm not trying to prove that transitivity is true, so I can actually use that within the proof without it being circular. So how can I say that if J is parallel to L and L is parallel to K, then J is parallel to K?
Transitive.
That would be the transitive property.
So it cannot ever be substituted.
And I'm about to say that in a second. Give me one second. Transit, I think I spelled it right. Transitive. Now, this is another thing that my third period kind of was bothered by. I don't know why. If you guys wrote substitution, that would be incorrect. And the reason why, substitution and transitivity are interchangeable only for congruency or equality, right? This is different. We're thinking about a different concept here because it's not parallel lines. We're not talking about measures or things being equal to each other. We're talking about a relationship between lines, whether they touch or not. So it's not the same thing. This is closer to a theorem than our substitution and transitive properties for equality. So you cannot, it's not interchangeable. For this one, you have to use transitive when you're talking about parallel lines specifically. Just be very careful you understand that. The reason why it's transitive, if you guys can see, is just like syllogism. P to Q, Q to R, therefore P to R. Whoa. It's just like syllogism, but with letters here. Why did you just do P? Because we're using J, L, and K.
What's the next one?
Okay. Is everybody with me so far?
Yeah.
Okay. The next statement, with the first three steps of the proof, I know that I have 3 sets of parallel lines. I only have 2 angles that are marked though. So with the parallel lines that I have, I only have 2 angles. I need some sort of relationship between the angles to move forward.
1 and 2 are consecutive interior.
Okay, so 1 and 2 are consecutive interior, which would say what about them?
The one is equal to the other.
Yes, they're supplementary. So angle 1 plus angle 2 no, not equals 180. Right? They are consecutive interior. So that's the consecutive interior angles theorem, which says because the lines are parallel, those angles are supplementary. Right? So I got that. That was my conclusion from the first set of givens. I can't do anything more from there until I bring more information in. So that's why they have a third given. I'm going to bring that in now. Angle 2 is equal to angle 1. It's the third given that I was provided. With this new information, I can take my first equation, angle 1 plus angle 2 equals 180, and I do what? I substitute, right? This is not transitive, right? Hopefully you guys see the difference between when transitive and substitution are interchangeable. This is not transitive. You're not saying 2 things are equal to each other. You're literally plugging 2 in for a 1. That's substitution, and you don't have any other option. So substitution. I'm plugging the 2 in. The plugging in property. Substitution.
Plugging in property.
The plugging in property. Substitution. Alright, before we move on, I have a question for you guys. Why didn't I use the 1? Why didn't I do 1 plus 1 equals 180? Why did I decide to use 2? Well, I could have said that 1 plus 1 is equal to 180. If you guys look back at the picture, we're trying to prove K is perpendicular to M. Would 1 help you figure that out? No. So always make sure you're glancing back at the proof to understand which angles are relevant to you when you have too much information going on. So I'm going to focus on angle 2. What property lets me do this?
That,
Simplify, combine like terms, whatever. I can't remember if it was this class or another one, but I had a couple people on the Unit 2 test. Whenever we did something like this that was really combining like terms, because we're adding things, some of you guys said it was the addition property. Remember, the addition property is when you add the same thing to both sides of an equation, the equal sign. It doesn't mean combine like terms. So you have to be careful you know the difference between those. All right, now what? Divide by 2. So now, if I know that 2 angle 2s is 180, then 1 angle 2 must be 90, right? Using the division property. I divide both sides by 2. Now what? I need one more. So this is another thing a couple people forgot on the test. There is a line in between having 90 degrees and perpendicular. What's the line in between there that you need? You need to say it's a right angle. Angle 2 is a right angle. You must include, you cannot go straight from 90 to perpendicular. You have to have that middle step to say that it's a right angle first. That's because of, nope, definition of right angle. Right? Listen, the definition of perpendicular, listen guys, the official statement, I think it's somewhere in your Unit 2 or Unit 3 packet. Perpendicular lines are 2 lines that intersect to create right angles. You have to take the exact wording of the definition into consideration when you are creating a proof. In order to say that something is perpendicular, you must first have that it is a right angle, and vice versa. If you're trying to say that perpendicular lines give you 90 degrees, you have to have that step that's the right angle first. So now that I know 2 is a right angle, how can I conclude that I have perpendicular segments? Definition of perpendicular. Right, so it goes 90 to a right angle to then perpendicular. Question. Alright. We're going to prove the alternate interior angle's converse. We've used this already, right? We know it's true, but we're going to use a mini proof here to show why it's true. So remember, this is the alternate interior angles theorem converse, so we cannot use that within the proof. Don't use circular reasoning. You can't use that within the proof to prove itself. Circular. So, I know. We have a transversal, and then we have angle 3 is congruent to angle 4. So I'm gonna abbreviate that. I'm gonna say line T is a transversal. Abbreviate. I'm fine with that. And then I also know that angle 3 is equal to angle 4. The only reason why I'm putting them both on the same line is because this first given doesn't tell you anything apart from this. So I'm putting them together so I can use them together. And that's given. Alright, now remember, this is the alternate interior angles theorem converse, so I cannot immediately say, oh, because they're alternate interior angles, the lines must be parallel, right? That is what the converse says, so you can't use circular reasoning. You can't use alternate interior angles here. You have to use something else. So is there anything from the picture you guys can tell me that might come in handy?
Vertical.
Vertical, you guys see vertical?
Yeah.
So what can I say?
Angle 3 equals angle 5.
Yep. Angle 3 equals angle 5 because vertical angles are congruent. Okay. with that new information that I have, what can I follow up with? Angle 4 is equal to angle 5. You guys see that? Substitution, or you could also say transitive in this particular situation because we're talking about equality between two different relationships. So now, instead of using my alternate interior angles, now I've switched it to what type? Corresponding. That's different than the alternate interior angle, so actually I can use that rule to help me prove this scenario here. So now that I've switched it to the postulate, which remember postulate is always true, you don't have to prove that one, how can I go from the fact that 4 and 5 are congruent to conclude that my two lines are parallel?
Postulate converse.
Yes. Because I have corresponding angles that are congruent, I can then say that the lines are parallel based on that converse. So the two lines are parallel because corresponding angles, postulate. Is it the postulate or
Yes.
the converse? So converse, because you're going from angles to lines. Right? Everybody good so far? This one's pretty, yeah. This one's pretty similar. I want to try the ones on the next page because they're much more interesting. I think we're going to skip this one for now. It's, listen please. Listen please. So this theorem, we're not going to, if we have time we can come back to it, but this one's very similar to the one above. We cannot use consecutive interior angles to prove it, because that's what they're wanting us to do, to show why that would work, so we can't use circular reasoning. So you guys would say that these two are supplementary, and then we have a linear pair which are supplementary, which would get you two corresponding angles, and then blah, blah, blah. You almost always just boil it down to corresponding when you're trying to prove these things. But if we have time, we'll come back to see that in detail. But I want to talk about these. All right? Let's talk about proof number 5. Proof number 5. What do I know? What do I know?
Line AB is
Parallel.
parallel to CD.
Segment AB is parallel to segment CD. Given. Although technically CD is a ray, but that's okay. All right. So if you guys want to, and it's really helpful when you guys have all sorts of lines going in different directions, to highlight the ones that are parallel. Doesn't matter whether you're solving, you're proving, highlighting the parallel lines is very helpful. All right. Based on those two alone being parallel, what can you guys tell me?
5 and 1 are corresponding angles.
Okay, 1 and 5 are corresponding angles. Is there more? Yes. 2 and 4 are alternate interior. Yes.
Can you say linear pairs?
We do have linear pair, but do you see how in the proof there's no 180? Linear pair is not going to be helpful. So there are two different relationships that you guys can get from these parallel lines. The fact that 2 and 4 are alternate interior, and that 1 and 5 are corresponding. Use two different transversals for that. Which set of angles would be most helpful in this proof in particular? 1 and 5. The 1 and 5. Okay? They are corresponding, and the reason why is if you use this right here, that's the transversal. All right, so 1 and 5 are corresponding. What do I know about them then? They should be equal. So angle 1 is equal to angle 5 because when you have parallel lines, the corresponding angles are congruent. So what rule says that? Corresponding angles postulate. Not converse, just the postulate. So we're going from lines to angles this time. You start with the lines, it's just your regular postulate or zero. Alright, so now what? You don't need to mention the 2 and the 4 being congruent because there's no 2 in the proof, so you don't really. Wait.
Yeah, there is.
Yes, there is. There
Why
actually is.
wrong?
I don't know. As soon as I said that, I realized I was wrong. I don't know what I'm doing. Alright,
Angles 2.
so angle 1 and 5 is a good place to start. Angle 1 and 5 being congruent was a good place to start because we knew that the other given has a 5. So actually a couple different ways we can go from here. Do you guys want to continue with the parallel lines or bring the next given in? You want to bring the next? Okay, we can bring the next given. That's angle 4 is equal to angle 5. And you can go in a different direction. You can keep working with the parallel lines before bringing this in. You'll see what I mean in a second, but you can do it whatever order you want. So I know that because it's given. So if I previously knew, and here we go again. Alright, if I previously knew that 1 was equal to 5, now I know that 4 is equal to 5.
1 is equal to 4.
1 is equal to 4. Okay? And what property? Substitution, or if you choose, you could also use transitive because we're doing equality here. Two equalities you can put together. Alright, that's all I can do with this information now. Okay? But now, the reason why I took back that statement about we don't need the 2 and the 4 is because when I look back at the proof, I see there is angle 2 involved. So I do need to bring angle 2 into the picture. How can I do that? Angle 2 is equal to angle 4. Now, you guys already told me this previously, but can you remember what rule would I use?
Zero.
Alternate interior angles 0. Because I know the lines are parallel, that means the alternate interior angles are congruent. And now how can I get to my final step of 1 being congruent to 2? Substitution. Oh. Oh my goodness, stop it.
Four thinks it's a finger.
Okay, I'm sorry for your computer broke.
I know.
What if you hold it as an angle?
I've tried so many things. I'm surprised that it hasn't glitched more than it has right now. So don't jinx it.
Glitch.
Don't.
Right? Everybody follow? See, sometimes we need multiple different relationships from the parallel lines.
Look, see, it's not glitching.
I know. Okay, let's try to do this one. Angle B is equal to angle D.
So we can draw that. See, I told you what it was.
Yes. Alright, I know that angle B and angle D are congruent based on my givens. Can't really do more with that, so I'm going to bring in the next given. Segment BA is parallel to segment DC. Alright, this is what we have. We're trying to prove that the other 2 segments in the picture are also parallel. So, those 2 ones that I've highlighted already are parallel, so is there anything I can get in the picture?
Angle AB.
You can just, because the letter is talking about the vertex, you can just use the letter instead of the 3.
Is angle B congruent to angle D because they're alternate exterior?
Nope, because that is a transversal. You can't, D and C don't have a relationship right now because they're not between the parallel lines. C and D are resting on one transversal, so. B and C. Okay, B and C. C is this angle right here. Do those 2 have a relationship?
Yes.
Are any angles?
They're points, yeah.
Alternate.
Yeah. If you guys see this as a transversal, what do you know about angle B and angle C? Yes, so angle B, yep, because they're alternate 0. The only one that's a postulate corresponding. So alternate interior angle 0. Now what? I have B and D are congruent, then I just said that B and C are congruent.
C and D.
C and D. C is congruent to D.
The substitution.
That's a that's a B. I apologize. It looks like a B. Sure, yeah, sure looks like a B. That's supposed to be a D. Shush. This is substitution. Substitution. That's definitely a D. I don't know what you're talking about.
I honestly think that is a
Kind
B.
of looks like a.
Like, look, you see? It's a B.
Whatever. So now I have this.
See, even mine says B.
Why can I now conclude that BC would be parallel to DE?
Because
Corresponding triangles.
We don't have any corresponding here.
Oh, because B and C.
We're using these
here.
now. We're using these now. We're trying to prove that these are parallel. So if we treat these as the parallel lines, Irene, like you were kind of thinking about before, if these are the parallel and that's the transversal, then C and D would be correct. Right?
What'd you with the C and D? Oh, wait,
Yeah, so this time we're using the alternate interior angle theorem converse. Say again? Step 2, this one? Oh, when you look at this picture, when you have the, I wish I could use switch colors, but I'm afraid of myself before. These two lines, Daniel. Darn it. Hold on. Lock.
Control K. I told you it existed.
These two lines and this transverse will help you see that you have alternate interior angles.
Oh, wait, are those lines
So if
parallel?
you use a different color, it can help you. Yeah.
Wait, so
That's what we're trying to prove.
that those lines are parallel?
Yes.
Okay.
Alright, I want to give those of you who haven't finished the grade assignment time to do that. So if you haven't finished the grade assignment, please do so in the last 10 minutes. If you would like to keep working on the proofs, feel free. I'll walk around and let you know if you are correct. Okay.
What if we don't want to do either?
That was not what we asked.
I know, but like, what if, like,